Recently, India launched its third moon mission, costing a whopping $75 million with the name Chandrayaan-3. This mission is going to be the most difficult one for the Indian Space Research Organization to date. In today's video, we are going to see the main objectives of this mission, what India learned from its past mistakes and how it improved, what devices are enabled in the aircraft, and why India wants to go on the moon for the third time. Around 4 years ago, India attempted its second moon landing mission with its Chandrayaan-2 aircraft. It consisted of an orbiter, a lander named Vikram, and a rover named Pragyan. The mission was launched on July 22, 2019, with the aim of studying the lunar surface, conducting scientific experiments, and searching for water on the moon's south pole. However, during the landing attempt on September 7, 2019, the lander deviated from its intended trajectory and communication was lost. The aircraft was only 400 meters away from the moon's surface and it failed to land due to the glitch. Now, Chandrayaan-3 aims to rectify this mistake and open a golden opportunity for India to show its technology to the world. ISRO has set 3 main objectives for the Chandrayaan-3 mission. Number 1. Getting the lander to land safely and softly on the surface of the moon. So far, there are only 3 countries in the world that did a soft landing on the moon's surface: China, Russia, and the USA. Soft landing a lunar module means going from the screaming speeds of over 6,000 kilometers per hour to 0 and landing on the surface without damaging the aircraft. If ISRO executes a soft landing, they will be able to take up international space projects which will help them in getting huge sums of money as well as boosting the Indian economy. Number 2. Observing and demonstrating the rover's loitering capabilities on the moon. After the spacecraft lands on the moon, it will deploy a rover to explore the lunar surface. The rover will collect data on the composition and geology of the moon, which will help scientists learn more about the history, potential for resources, and evolution of our nearest celestial neighbor. Number 3. In-site observation and conducting experiments on the materials available on the lunar surface to better understand composition of the moon. Chandrayaan-3 will conduct a series of groundbreaking experiments using its payloads Ramba and Ilsa. These experiments will study the moon's atmosphere and dig into the surface to better understand its mineral composition. The lander Vikram will photograph the rover Pragyan, which will deploy its instruments to study seismic activity on the moon. Pragyan will use its laser beams to melt a piece of the lunar surface, called regolith, and analyze the gases emitted in the process. Through this mission, India will not only access a wealth of knowledge about the lunar surface, but also its potential for human habitation in the future. The space shuttle is expected to land near the lunar South Pole region of the moon, where sunlight has not reached for billions of years. This is because 41% of the moon's surface is always covered by the Earth, which blocks the sunlight. By studying the craters present there, scientists may be able to gather important information about the origin of our solar system. But that's not all. They may be able to find essential resources like silver, mercury, methane, sodium, hydrogen, and a lot of water. So, this location might become a pit stop in important future missions. Now, let's look at the key updates in Chandrayaan-3. Firstly, the lander does not have wheels. It has stilts, or legs, which are supposed to touch down on the lunar surface and then stabilize. Chandrayaan-2 lost control over its descent around 7.2 kilometers from the surface of the moon. The lander had slowed down to about 580 kilometers per hour when it crashed. The legs of Chandrayaan-3 have been strengthened to ensure that it would be able to land and stabilize even at a speed of 3 meters per second, which is approximately 11 kilometers per hour. Secondly, the Chandrayaan-3 lander mission is equipped with lander hazard detection and avoidance cameras for coordination with the orbiter and the mission control during the landing process on the surface of the moon. While Chandrayaan-2 had just 1 such camera, Chandrayaan-3 has been fitted with 2 such cameras. Another addition to the Chandrayaan-3 mission is the laser retroreflector array being sent with the lander, which is a passive experiment to understand the dynamics of the moon system. The other 3 payloads being launched with the mission are the same as that of the Vikram lander on Chandrayaan-2. Moreover, the spaceship has additional solar panels on other surfaces to ensure that it generates power no matter how it lands. Also, if you didn't know, the moon is a great platform to study Earth, so Chandrayaan 3 has special instruments attached which can be used for weather pattern detection and eventually help plan future missions. Lastly, the budget of Chandrayaan 2 was approximately $106 million, whereas the cost for the third mission is $75 million, which is significantly less. Chandrayaan 3 is expected to land on either August 23rd or August 24th, 2023. If landing cannot happen on these two dates, ISRO will wait for another month and land in September. Once landed, it will conduct operations for approximately 1 lunar day, which is equivalent to 14 Earth days. Thanks a lot for watching this video. Let us know your thoughts in the comments down below. Also, if you haven't already, make sure to like this video and subscribe to our channel. We will see you in the next one. Bye!